All right, CNT125, we're looking at Chapter 11, Security and Network Design. Um, with security, we introduced some topics in Chapter 10. We're adding some in Chapter 11 because as we look, security really has to be done in multiple layers, multiple methods, if you will, to secure your network. In a zero trust security model, everything in the network is considered untrustworthy until you can prove otherwise, until you have some means in place to verify that it is trustworthy. All our devices, routers, switches, servers, everything are at risk. So there needs to be something in place to protect them and or ensure that they're operating without being compromised, if you will. So that brings us to security has to be done in multiple layers, which is why we're adding some additional topics in this chapter. One of the first ones they tackle in this chapter is access lists, ACLs, access control lists on network devices. Our router's main function is to examine packets and route them to where they need to be based on IP address. Some security can be offered by our switches and routers. If we think back to, we did VLANs early on, that is a level of security that switches can offer. Well, routers can offer a level of security through ACLs, access control lists. Routers can be set up to forward or decline packets, certain types of packets, and acts like a filter to either permit a certain group of traffic on or deny a certain group of traffic based on a criteria. And I think the book uses the example of like this acts like a bouncer at a nightclub. You know, yes, your ID is valid, go ahead and come in. No, your ID is not valid. Sorry, you cannot come in. That kind of thing. Some variables that the access control list can do and permit or deny, we can write it to permit or deny based on, is your network layer protocols, examples IP, ICMP, transport layer protocols, TCP or UDP, and think about all the TCP port numbers we've mentioned or learned. Those are all variables. Source IP address, where are you coming from? Are you coming from this subnet or this subnet? Are you coming from the employee subnet? Go ahead. If you're coming from the visitor subnet, no, you can't. And with that, where are you trying to go? Are you trying to go out to the internet? Okay. Are you trying to go to the part of our network where we have all the servers? No, you can't. Okay, that kind of thing. And TCP or UDP port number, what protocol are you trying to use? And again, this is kind of like we can filter on TCP or UDP, but then we can also drill down further and go to a specific port number. Yes, you can with this port of traffic. No, you can't with this particular port of traffic. So router's going to receive a packet, examine it. It'll then refer to the access list for permit or deny criteria. You know, this packet of, let's say it's HTTP. Do we see a deny HTTP? No. Do we see a permit? Okay, yes, we do see a permit, so go ahead through. So it's going to look for that permit or deny criteria. It's going to drop it if it matches the deny criteria. It's going to forward it if it matches a permit criteria. If the packet doesn't match anything, if it doesn't match a deny or permit, it's going to get dropped anyway, because there is, at the very end of your access list, there's an implicit deny rule. It's not actually, you don't actually see it there, it's just there by default. This is there really to save your rear end. If all your permit and denies don't deal with a certain type of traffic, this sitting at the end of your access list is going to deny it and basically cover you in the event of you forgot to write a line to permit or deny a certain type of traffic. So it's actually very helpful. I don't always have to explicitly permit the traffic. It's going to get denied with this, which is handy. But I have to remember it there, because if I haven't permitted it somewhere, it's going to get denied with the implicit deny rule. So it's going to be at the end of your access list. You won't see it, but it's there. That is your implicit deny. That is very handy to remember. So the gist is, incoming packet comes in, it's going to literally work its way down through these lines of the access list in order. Do the first test. Is it getting permitted or denied? Yes or no? Is it getting permitted or denied? Yes or no? And it keeps working its way through until either the traffic is permitted through or denied. And if it doesn't match any of these criteria at the end, it's like, okay, well, it's going to get thrown out. It doesn't match or permit or deny, it's going to get thrown out. We're assuming it's some other type of traffic. We're worried, you know, maybe it is a compromised type of traffic. Most routers, each interface must be assigned a separate access list. So if I have two different interfaces, one access list on one interface will not affect the traffic on the other one, and vice versa. I might need to write more than one access list to filter the type of traffic I want. So I'm going to use this example. Think of having a security guard at the door of our lab room. I can do one of two things. I can have that guard check traffic coming in, or I can check traffic going out. So I'm giving you an example here of I might need to give this security guard two different rules. One to check traffic coming in, and a second one to say, okay, check traffic going out as well. So the going in, I might tell the guard at the door, okay, check backpacks coming in to the lab room to make sure that students are not bringing soda, beverages in that might get spilled on the lab equipment. So we're going to deny soda and coffee and so forth coming into the lab room so we don't have things spilled on the equipment in the lab room. So as you come in, it's going to check your bag. Hey, do you have a can of soda? Okay, no, you got to take that out. I might also then have a second rule, or a second security guard, if you will, a second rule having the security guard check the backpacks on the way out. And here we're going to tell them, okay, I don't care if they take soda out. I just didn't care if they brought it in. I want to make sure on the way out that they're not taking routers and switches out of the equipment rack. So we'll then do a rule to say, hey, check the bags to make sure they're not taking routers and switches out of the room. And we're going to deny them exit the room if they have a router or switch. They're not allowed to leave. And this is just to make sure, equipment is getting stolen out of the lab room. And I'm smiling when I say this. Just giving you an idea that I might actually write two separate rules. One to check traffic coming in and one to check traffic going out. And they would be two different sets of rules. And that's what this is telling you right here. If I have two interfaces, I might have two different access lists checking traffic going one way and traffic for something else going the other way. So, again, it's going to check the criteria, permit or deny, and if it doesn't match any of those, it's automatically going to get denied. If it doesn't match any of our criteria, it's going to get denied. So if I have a piece of FTP traffic, file transfer protocol traffic, it hits the first rule that says deny telnet. Well, it doesn't match that, so it's going to go to the next rule. The next rule says deny FTP. What matches that? It matches the FTP, so it's going to get denied. It's going to get thrown out. Done. That traffic will not get through that interface. If I have a piece of web traffic, HTTP, well, it doesn't match telnet. It doesn't match FTP. But it doesn't match IP because HTTP uses IP traffic. Okay, it does match IP, so it's going to get permitted. This traffic would actually get through this firewall rule. Excuse me, this access list rule. So the command to assign an access list is literally the access list command. And I then assign that and I start assigning numbers. If I have more than one access list on my router, I might have one whole set of access lists being used. 101 would be the rule number, and the second access list I might do 102, and the next one I might do 103. That way I can keep them separate. I do need to remember that adding access lists affects my router's performance. Think about the security guard at the door of a room. The more things I have them check for, the more it's going to slow down people coming into the room. And same thing on the way out. If I have them check for, 10 things versus 5 things, it's going to take longer for people to get out. Okay, so it does affect performance. Here is the syntax. I use the access to command followed by a number. And any rules for that filter list would have the same number, 102, 102, 102, 102. That way all those rules are kept together. When I write a new access list, I would use a new number, 103, keep all those together and so forth. I then use the permit or deny command, followed by the protocol. This would be either IP, TCP, UDP, that kind of thing, kind of like the protocol umbrella. I then indicate the source network, followed by the destination network, where are you coming from, where are you going, and then I then would get specific on the type of protocol. In this case, it's usually a port number. Example 80 for web traffic or 443 for HTTPS traffic. So the port numbers you learned back in 120 will be helpful now, will be really helpful now. That is the syntax for writing a rule, an access list rule. And then I'm going to use the access group command to apply that. So once I write all the rules, I then go to the specific interface I need to apply it on. And then I say IP access group, and I use that same number. If I use 102 up here, I would use 102 here and say, okay, access group 102, we are going to apply that coming in or out of that interface. And think about the security guard example. I'm going to roll back here real quick. Think about the security guard example. Do I want it checking traffic coming in that interface or going out that interface? Do I want to check traffic coming into the lab room or out of the lab room? That's what I need to think about when I use this. So let's look at a couple examples. If I want to deny telnet traffic from coming in to our network from the internet. So out here we have telnet traffic trying to come in. Maybe it's trying to telnet into the router, switch, something, server. I want to deny that. So I would write access list 102. Anything below 100 is what's called a standard access list. We're using extended access lists, which are 100 and above. This gives us more parameters. This gives us more variables that we can do. When we did our NAT configuration, we used the standard access list of like access list 1, access list 2, access list 3, and that was a very simplified access list. Now that we're using numbers above 100, it gives us more parameters here that we can permit or deny on. Okay, so we're using 100, 102, 103, 104 kind of thing. Okay, so access list 102, we're going to deny, because we're trying to deny telnet. Telnet is part of TCP, or Telnet uses TCP. We're going to deny it from coming from any network in the world, going to any network, in this case anywhere in here, equal to 23. 23 is the port number for Telnet. 23 is the port number for Telnet. We're then going to permit the other remaining IP traffic. Now, in real life, that is not a good rule, because we don't want to permit all other traffic coming in. However, this gives you the idea of this is how I would deny telnet. This line right here would deny telnet. I would then go to this Ethernet 1 interface right here, and I'm going to apply this access list, access group 102, 102, 102, and I'm going to apply it coming in. So I'm just going to say here, hey, on this interface, check traffic coming into, from the internet coming into this interface, check it, and deny telnet. That would deny telnet coming into our network. If we want to deny FTP from leaving our network, we want to make sure employees are not sending files out. We're going to use, we're going to deny FTP, which is 20 and 21. There's 2 port numbers for FTP. So we'll do access list 102. Well, this could be 103 if we're writing a new one. Access list 102, deny TCP. FTP uses TCP. Coming from any network, going to any network, equal to FTP. That's 20. That's 20 right there. I can use name or port number here in many cases. That's why I'm using the name here for you. Access list 102, deny TCP from any network going to any network, equal to FTP data. That's the port 21. That's the port 21. And then we're going to permit any IP traffic after that, IP any. Okay, again, that is not a great rule in the grand scheme of things. We're allowing all the other traffic, but these are the rules that would deny FTP. So we'll then say IP access group Ethernet 0, IP access 102 in. Over here, Ethernet 0, we want to make sure that we're filtering the traffic coming into that interface. Okay. Now, if we want to get more specific, we can do it based on a certain subnet, a certain group of users. And I can specify certain network subnet, certain specific network segments, groups of IP addresses. This is done with a wildcard mask. Think of this like your inverse mask. 0 is going to match the IP address bits, network or subnet portion, and 1 is going to say basically the host portion, I don't care. Okay, so if we take a look here at this example, we want to deny FTP traffic from the wireless users, which is the 10 network over here, 10 network. We're going to say access this 102 deny TCP, and we're going to say the source network, and we're going to plug in the 192.168.10 network. And we'll use the inverse mask, the wildcard mask, 000255. That's our inverse. Equal to FTP, and then do the same thing for the FTP data. And then permit IP any. Okay? And that would allow us to filter just this group of users and not affect these users at all. I'll come back in the next podcast and continue.